Hello students, my name is Sumit Sagar Hota. I am a PMR PhD scholar IIT Palakkad. This is the week 1 of the live discussion section of the subject Introduction to Airbreathing and Propulsion by Professor Ashok Desai, IIT Kanpur by NPTEL. So in this section we will see some of the problems related to your week 1 and some of the MCQs, mostly all are MCQs, okay, related to that lectures. And let's start the section. Sorry for the slight delay. Okay, we may start some 5 or 10 minutes maybe. We can just see what's the where actually I taken. So this is the just write down the basic things. Okay, numerical problem cells in sections. Okay, so let's start with our first problem. So which of the following is not an aircraft propulsion system? Okay, so if you in the sections I will actually directly go through all the question then answer. If you know the answer you can write down in the chat box also, and if you have any doubt you can directly ask me. Okay, so let's start. So for this, which of the following is not an aircraft propulsion system? So obviously if it is a reciprocating engine, rocket engine, obviously it is a aircraft propulsion system. Then if it is a piston, obviously piston engine it can be used in the aircraft propulsion. Then reciprocating engine, okay, reciprocating engine also used in the aircraft propulsion, but there is no such device like high lift device. Okay, this is not a aircraft propulsion system. Then what is this? So we have to now see it. Okay, so a high lift device. So this lift, as the name suggests, it is used to increase lift with whatever lift produced. Okay, what is the example of these high lift devices? So very good examples are flaps. Okay, so why these flaps are used in any kind of aircrafts? So obviously for what? Your takeoff and landing of aircraft. Okay, so the first questions answer done. So let's go for the second one. Which of the following is not the type of an aircraft? Airbreathing propulsion, obviously as the name suggests, or the obviously the course name also same. So obviously this is a type of aircraft. Non-airbreathing systems are nowadays used. This is also the case because where there is no air, especially in the space, we use this non-airbreathing system propulsion. Especially rocket engine uses both. So this is the case, but this long range is not a aircraft propulsion system. Okay, so what is this? We just get to know. the longerons is the structural elements of an aircraft. The structural element of an aircraft. Okay, so what it helps for? Okay, so any kind of aircrafts which helps in, it prevents the what? Bending. The longerons are helpful in the aircraft to prevent the bending. And obviously, if it prevents any kind of bending in the system, that means it's obviously a heavy element, heavy structural member that run always straight. Okay, at the middle of the aircraft. This is heavy structural member. Okay, so the answer is A. So the next question, which of the following is an advantage of the piston prop engine? Okay, so piston prop engines are very old age engines. Okay, widely used during the early era. And this is obviously a cheap one, but not effective. Obviously, it's also low fuel consumption. So everything is good, then why we stop it? So because it cannot go very high speed. Okay, so that's what the question. Next question, which of the following is a part of turbine engine? Okay, so obviously these are all flap, aileron and elevator. All these are not the part. Compressor obviously is a part of what? Turbine engine. This is more specifically, if it is a one word, we can always use integral part of turbine engine. Okay, so flap, what is a flap? Flap is a secondary control surface, and this aileron and elevator, aileron or elevator are the what? Primary control surface. So what kind of motion this aileron and elevators do? The motions are rolling motion, and elevator obviously will do pitching motion. Okay. So next one. Okay. Um, a typical turbine engine consists of what? Obviously, a typical turbine engine consists of a combustion chamber, a turbine, and a compressor. So first one. Combustion chamber, mostly represented by CC, then turbine, T, and compressor, C. But in place of this question, if one more question will be asked, what is the change in between the turbine engines and the fighter aircrafts? So in fighter aircrafts, your combustion chamber is there, your turbine is also there. Exactly, afterburner. That's truth. So compressor is also there, and the afterburner or afterburning section we can write. Okay. So why this afterburning section is there? To increase the what? Efficiency, because we are reusing again that heat whatever is there exhaust having in the exhaust gases. Okay, so that's the case in the afterburning section. So next. Okay, now what is the function of a compressor? Okay, it's a very simple question. To increase the pressure and temperature, this is the first one. So what exactly it do? It just compresses the flow, and in return the pressure is increases and the temperature also is to decrease. So what is the velocity? The velocity will decrease. Okay. So that's what the whole case. Let's go to the next one. What is the use of a turbine? Okay. So basically it always generates the work to drive the shaft. Let's write down. So combustion products is reduced. The pressure will reduce. That means the temperature will obviously going to what? Reduce. If the temperature also reduce, pressure is also reduce, the velocity is obviously going to rise. So in return, what it exactly do? Generates work to drive the shaft. In return, the compressor will work. Okay. So the next one, which of the following is correct? Obviously the same thing I now told. Compressor consumes the work produced by the turbine. Okay, so just directly go to the next one. Which of the following is a type of compressor? Okay. So there is only one type which is correct here. Other are not the type. It's wrong options. Obviously there is no incline compressor. There is no flap. There is no rudder compressor. So centrifugal compressor is the right answer. So what exactly this centrifugal compressor will do? It uses centrifugal force to fling the air. Okay. So next. So this question, okay, we can see one diagram here. Okay, so in this diagram we have to tell what is the type of diagram is this. Is it a piston prop, is it a turboprop, or a turbojet, or a rocket? Okay, so you can very easily see here one. In this question you can easily see here one propeller is there. Okay, and also one piston cylinder arrangement is here. Okay, then in the type of system where one propeller is there and one piston cylinder arrangement is there. Okay, not necessarily here this question is very simple. Why? Because it's already written, it's a propeller and a piston cylinder arrangement. In some question they may not write all these things. Okay, so this is a okay, so this is a piston and propeller, that means piston prop. Okay, so what exactly this piston pump engines do? It uses piston and propeller blades to generate useful work and thrust. due to which the aircraft can go forward. So what is the disadvantage of this piston prop? Obviously, because of this piston cylinder arrangement, which dead weights are there. So this is due to which it is a heavy system, and because of piston cylinder arrangements, there's some it uses some what? Sorry, it it is because it is little noisy. Okay, it produces noise. Okay. So that's the case. So next we can see one diagram also shown. We have to see what type of is it a compressor engine or aircraft, whatever it is, you have to see it. Okay. Okay, so in this design, if you can really see, one combustion chamber is here, one turbine is there, and one exhaust whatever, and one centrifugal compressor is there. So but if you see in this question, this question is obviously very simple, because they actually retain this centrifugal compressor part. Okay, maybe in your exam some questions will be there, they don't write that much straightforward. Okay, they mention here in the right side centrifugal compressor, but they are not going to give in the option centrifugal compressor, then it will be little difficult. Okay, so now it is centrifugal compressor means obviously other three options you have just better to leave, and this is the option. Okay, but actually this is a, because if you can see here, turbo prop cannot be the case, because here there is no propeller attached, so this cannot be the case. Piston prop, here there is no piston arrangement is there, or a piston engine. Okay, there is no such kind of piston engine is not there. Okay, piston engine we can think of our two-wheeler or four-wheeler vehicle, it cannot be aircraft or aircraft propulsion system. So this is not a correct way of telling. If there, then the turbojet engine can be the case, because turbine plus combustion chamber is there and one compressor is also there. So it's obviously a case of what? Turbojet engine. Okay, since it's consists of centrifugal compressor, so it's a turbojet engine with centrifugal compressor. Okay, not necessarily they don't mention also compressor, only with diagram you should know. Okay, so let's write down what. So answer is here. And so in this engine, the centrifugal force drive this engine. Okay, let's do it. So next question. So here also one diagram is there. Okay. Yeah. So this is a very good diagram of your what? Turbojet engine, because now I already told all this thing about the turbojet engine. This is the basic design of a turbojet engine. One compressor on the left side, turbine on the right side, and there is one in middle. It is connected through the what? Combustion chamber, and there is one shaft going in between these two. Okay. The shaft drives the compressor. Okay. So this is a typical turbojet engine. So operated by which kind of flow? Okay, it operated by what? Axial flow. Okay. Okay. So next one. So next question, you can have to tell what kind of engine is this. Obviously here you can see also one compressor is there, then one combustion chamber and turbine. Okay, if this only these things will be there, then it will be turbojet. What is the extra? Here one propeller is there, and obviously because of propeller it have to operate through what? Gearbox, and that gearbox through the compressor. That means turbine, through turbine which drives the shaft, then the compressor will rotate, and because of a compressor rotate, it will rotate the gearbox. Okay, and because of that gearbox, that means it can enhance the rotating. Okay, maybe some 1 is to 5, 5 is to 1. Okay, whatever these gear ratios are there, and due to which this your the propeller can rotate 5 times more speed or 10 times more speed than the compressor rotation. So obviously, so in this question there is no option of turbojet. Okay, so this actually they made it simple, or someone very well going to confuse. So it's actually propeller based turbine engine, which is a turboprop engine. Okay. Mm, here propeller. Okay, so it consists of what? The propeller, the gearbox, the compressor, combustion chamber, turbine. Okay, so the next question. So everything going to be same as the turbojet. One compressor, combustion chamber, and turbine. Okay, then the compressor drives by the what? One fan. Okay, so they actually write down the fan. That's very good, but sometimes they are not going to write down the fan or the propeller. They're looking same, but they're not the same. So very well you can see there are different designs of propeller. You can actually different way of representing the propeller. So sometimes they can represent like this, or it can be like this. Okay, something like that. Okay, so some kind of like this they can represent the turboprops. Okay, fan always look represent like the mostly the uh like this they obviously represent. Okay, it's nearly similar but not the same. Okay, and mostly one very good way of knowing how it's a fan and the propeller, mostly they use gearbox for the propeller, not for the fan. Fan does not require any kind of gearbox. Okay, but for propeller they may need the gearbox. Okay, propeller can be attached to the piston cylinder. Propeller can be attached to the gearbox, but fan cannot be attached to the piston cylinder, and fan cannot be attached to the gearbox. Okay, why I am telling, because there some means it's not necessarily that they will write down this is fan, this is propeller. Okay, not necessarily it is required to be written. Okay, so basically a turbofan engine so what I did do, the fan mounted at inlet. So we're really going to see, because of this fan, what is the advantage of doing this fan when we put it at inlet. Okay, so because of this fan the efficiency is going to what, increase. So this is the best advantage of turbofan. That's the reason why it's better than our what, turbojet engine. Okay, and this efficiency I'm talking about the fuel efficiency, not any other efficiency. Okay, so exactly, so okay, so that's what the whole idea. This can be very good question. What is the efficiency of the turbofan? Is greater than, less than, equal to, or none of these? The question can be asked. Okay. Now, which of the following method is used exclusively in fluid mechanics? Okay. So, if if somebody knows about the fluid mechanics, he obviously know both. He can directly go and click the D option, which is the both Lagrangian and Eulerian methods, which is absolutely a what, wrong answer. Okay, so because the Eulerian method are the methods which is used for the general state of motion at various points in the fluid system. Okay, but the Lagrangian methods deals with the motion of each particle. Okay, and in the fluid mechanics or any kind of flow which we will see day to day life, we are not here to see the each particle, or we cannot see each particle of a fluid. Okay, so that's the reason why the Lagrangian methods cannot be used in the practical problems of the fluid mechanics. So this is a bit tricky question. So the Eulerian method can be used very frequently in any kind of fluid mechanics problem for the practical applications. Okay, that's the reason why in Airbreathing and propulsion systems and all these practical scenarios, we mostly use the Eulerian method and we don't use this Lagrangian method. Okay, so that's the key of this question. So answer will be A. But it does not mean that it does not have any kind of importance of this kind of Lagrangian method. It's having its own importance. Okay, but in general, if you are telling me, then we use Eulerian method. That's the reason this continuum hypothesis, all these things are came into existence. Okay, Eulerian methods. Okay, but in macro level, Eulerian method is good. But in micro level, when we require to see the each particles, like one example I can give, if in our temples, if we see one of this sticks will be there having smokes, and if somebody want to see what is the somebody want to study is particle of the smoke, how it go, yeah, and how it influence due to the air and all these things, because it's not a laminar flow, it's a kind of turbulent flow. So those natures, if somebody want to measure, this can be possible through your Lagrangian method. Those things actually not here required in the Airbreathing and propulsion kind of system. Okay, so the the stagnation point is the point in fluid mechanics where the velocity of the fluid at that point is what? Very simple question. It's obviously what? Zero. Okay. So what is the example of stagnation points? If you see the fluid surface, it's actually we are assuming it as a stagnant point or stagnation point at that surface easily. Although in practical, if you always know that it's not stagnant, it's actually movement is obviously there. But if you really go to if you really go to uh, really want to relate this thing, we can go to the deep sea, and at the near to the very not to near the sea beach, but just a little bit deeper or little bit far away from the beach, and we can see that the water is a little bit still. There is no turbulence, all these things are waves, and all these things are not there, and exactly at that those point we can tell it as a stagnant point. Okay, so basically it's obviously a relative phenomenon, because our earth is also rotating, and nothing is stagnant at all. But yes, it's with relative constant, it's stagnant. Okay, so the next question: what is a model testing? Which model, which testing? That's the biggest question. So model testing, you obviously what? It's not a kind of overall model, means any kind of model you can tell to solve our problem through simulations. Okay, without doing the practical implementation. Before doing the practical implementation, obviously we'll do the model testing of any kind of phenomenon. Okay, if you see one aircraft and aircraft design, what will be the correct design of that aircraft? How we know? Obviously we have to flow the air, we have to make it a container. Okay, the 3D container, then inside that we have to make one geometry of the aircraft, then we have to put some air blow uh, through inlet, and with some high velocities for the maybe supersonic or hypersonic flows, and see the performance where there is this drag is high and where this lift is high. All this analysis we can do it, and accordingly we can redesign the aircraft and and finally we will do the practical implementation. So why? So that means what exactly we are doing? We are increasing the performance of the aircraft so that the drag, lift, all these things are less, and the fuel economy, it's a economical. It will be fuel economy. The system will be fuel economical. So there will be less wastage of fuels. So yeah, so the model testing is a performance testing. Okay, so some okay. So one just basic definition I can write down. The model testing is the process to study complex fluid dynamics and also use different types of scaling, all these things. So the next question: when a fluid is subjected to resistance, it undergoes a volumetric change due to what? Okay, so when the fluid is subjected to resistance, so this is the important term, resistance. What is the resistance? Undergoes a what? Volumetric change. Means the volume will okay, volume I can represent it by like this B. Okay, so volume will either increase or decrease. Okay, so resistance, it applying some resistance. Okay, and due to which the volume is changing. Okay, so volume is change can be cohesion, adhesion. These are different phenomena. They are not related to any kind of volume change. But yeah, if you do overcome compressing or expansion, this may be related to your volume change. Okay, so compressibility is maybe the factor. So this cannot be the case. So what is compressibility? So this measures measure of relative change in volume of fluid. Okay. So if we really going to see, because of a resistance the volume is changing, that means with compression we know very well if we compressing something, okay, expansion means volume will increase, okay, and compression means volume will decrease. Okay, so okay, so resistance they are telling, okay, resistance, and resistance means okay, here you can see the resistance leads to this expansion is not possible. Okay, due to resistance this expansion cannot be a possible option because they read directly written resistance. Okay, so this is a wrong option, so the compressibility is the correct option. Okay, so okay, and this due to this compressibility, that means what? The obviously due to this compressibility your pressure will what? going to rise, and because the pressure rising of the system, the temperature is obviously going to what? Rise, or it can be constant also. Okay, if we rise in pressure, we can make the system constant. This is possible in which case? When the system is very very big. Okay, so the maintaining constant temperature also possible. So sometimes this compressibility can be called as isothermal compressibility. Okay. Okay, so this is the important thing. So okay, so what is a compressible flow? Okay, the compressible flow is assumed to be hot. Okay, so sometimes some people are telling isentropic flow. Okay, one very good term somebody tell, isentropic flow. Okay, so this question will be simple if you know what is isentropic flow. Okay, so isentropic. So what is a isentropic flow? Isentropic flow is a reversible and adiabatic flow. Okay, so that means whatever the adiabatic options are there, and whatever these options cannot is not a correct option. Okay, if we are considering assumed, okay, we are putting on assumptions. Okay, and assumptions always put to the reversible one, not the irreversible one. Okay, because in practical the reversible system is not exists, rather irreversible systems are exists. Okay, so for any kind of assumptions we always choose the reversible one, not the irreversible one. Okay, so if there is an assumption means always we consider reversible. So reversible means, okay, reversible means the system is actually both way the system, the any kind of reactions are possible. Okay, so reversible adiabatic means there is no heat flow in or out of the system, and this is also reversible system. Okay, so these options cannot be possible. Isentropic and adiabatic, these two things cannot be work together, because one is a reversible, another one is irreversible. Adiabatic only also cannot be an option. Polytropic is purely a real system. Polytropic is purely a real system, and we cannot assume any kind of real system for a particular kinds of flow. So obviously one thing left, which is the isentropic flow. Okay, so any kind of compressible flow, we are assuming it as isentropic. It does not mean it's actually isentropic. Okay, we are putting on assumption. It's actually a basic assumption for any kind of compressible flows, because we are in kinds of aircraft, we are dealing with compressible flows, and for which it assumed to be isentropic flow. And because of isentropic flow, we can apply very different formulas, like PV to the power gamma equal to constant, TV to the power gamma minus 1 equal to constant. Okay, and pressure, temperature, like that, different relations we can use for the isentropic flow. Okay, so say compressible flow. So for the compressible flow, this is assumed to be isentropic flow. So obviously it means what? the compressible flow means there is a what change in density. That means it cannot be a what liquid. So if it is a liquid, you have to mix in such a way that it performs like a what, like a gaseous substance. Okay, so that's what the idea. Because inside the combustion chamber, when we use mostly kerosene based fuels, very high graded kerosene based fuels are used in the aircrafts, and for these cases in the combustion chamber, the we have to spray these fuels so that there will be a pre-mixed flame inside the combustion chamber, and so for these cases, the density is a kind of change. Okay, so it's not a constant density at all. So we have to track this change in density, how much density change we can handle. All these things we can see, all these thing. One very good term we can tell, if you really know the studied the gas dynamics course in the NPTEL or anywhere, so you very well know what I am exactly talking. For the especially for the high Mach number flows is taught in this course, the gas dynamics. Okay, so next question, what is the principle of fluid mechanics works on the utilization of what? Obviously it's a very good very simple question, rather it's very difficult, because the most of you I think going to select one very good option, which is either volume or the velocity, obviously, and those are the obviously the wrong options. Okay, the correct option is the work. Okay, so the principle utilization of utilization of useful work. Okay, this is the principle of what fluid mechanics. So the next question, the pressure variation for a compressible fluid is maximum for which of the following kinds of process? Okay, so now they are telling pressure, they are varying the what pressure. Okay. That means they are telling the pressure, whatever the pressure they are telling, it should go to the maximum value. Okay, but if the pressure will go to the maximum value, then what else the quantity can be kept constant and we can raise the pressure. Actually now I think 2-3 minutes before I tell this thing, if the pressure rises, the temperature can rise, but it's not that it can be also kept constant. Okay, for a bulk system like an aircraft or all these kinds of system, we can maintain also a constant temperature while rising the pressure to a maximum value. Okay. So when the pressure is rising to maximum value, that means so that means is the system will be compressible or incompressible. Obviously it will be a what? Compressible system. So we are using a the fluid which can compress. That means we are not directly using the liquid fuels. Okay, we are pre-mixing with air, then we are using it as a fuel in the combustion chamber. So which means this is a isothermal process. Okay, so the answer is C. Which among the following is an assumption for Hagen-Poiseuille equation? Okay, if you know actually what is a Hagen-Poiseuille flow, then obviously this question will be very simple. It's a basically Hagen-Poiseuille flow is a very good flow for the pipe. Okay, especially this is a laminar Newtonian fluid based incompressible flow for a pipe. Okay, so obviously if you see the options, only laminar is there, which is the correct option. Okay, so then which of the following is a formula for the friction factor of a circular pipe? Okay. It's a very common formula, but most of the people will confuse between the friction factor and the coefficient of friction for a circular pipe. So yeah, so sometimes some people who can choose for 16 by RE in play. So okay, they can confuse the what is the numerator or denominator. So in this way they can confuse. So yeah, so obviously the correct option for this question is 64 by RE. Okay, not the 16 by RE. If the coefficient of friction is there, then the answer will be 16 by RE. Okay, so friction. It should be noted that this is only valid for circular pipe and laminar flow. Only in these conditions this is satisfied. Other conditions it's not satisfied. And what this exactly called? Who is the inventor of this formula? The Moody, and we tell it as Moody friction factor. Okay, so which of the following is the mathematical technique used to predict the physical parameters? Okay, mathematical technique, that's the important statement. Okay, this is a mathematical technique which is help to predict what? The physical parameters, like what? Your, it can be a temperature, pressure, all these things. Okay, and it's a mathematical technique. Okay, so temperature, there is no such kind of analysis. Pressure, combustion, nothing like that. There is a dimensional analysis is the correct one. So this is based on fundamental units. Mass L M L T, sometimes theta for temperature. This is your length. Okay, so yeah, and this is your mass. So let's go to the next one. So which of the following have the same forces acting on them? Which among the following have the same forces acting on them? Okay, there is different kinds of similarity analysis are there: dynamic, geometric, conditional, and kinematics. Okay, so obviously the dynamic similarity always deals with the forces. Okay, the force written means it's related to your dynamic analysis. So we called it dynamic similarity. So what does it mean? It means same force acting on fluid particles. What does it mean again? The ratio of all forces acting are what? Constant. Okay. So we just solve a simple problem. If a piston cylinder with a cross-sectional size of 0.01 meter square is resting on the top in the stops, what should the water pressure be to lift the piston with a outside pressure of 100 kilopascal? Okay. So what are the things given in this question? So area given 0.01 meter square, P naught 100 kilopascal, 100 into 10 to the power 3 is equal to 10 to the power 5 Pascal. And what we need, the water pressure to lift the piston, let it be Pw. So the solution, so what is Pw? Pw is equal to P naught plus whatever the mass it's there, okay, mass of the what? Piston. Okay, we have to lift that pressure, we have to handle that pressure, as well as we have to lift that piston. So both things are added together. Okay, so piston weight given mp into g divided by cross sectional area, because this is a force and we have to convert it to pressure, so we divided it by cross sectional area a, which is already given, okay, 0.01 meter square. So 10 to the power 5 plus your weight is 100 kg, z 9.81, and divided by cross sectional area 0.01 meter square, which leads to a value of 198 into 10 to the power 3 Pascal, which is 198 kilopascal, which leads to a option of C. Okay, so let's go to the next one. Which of the following is the standard fixed point of thermometry? Okay, so the standard fixed point is always a triple point of water. Okay, okay. So next question. Okay. 28. Which of the following gives the mechanical efficiency of the engine? Okay, so obviously you know very well the brake power is always less than the indicated power. Okay, so in for efficiency calculation we'll always put the numerator as the lesser quantity and the denominator as the higher quantity. So the mechanical efficiency, the formula will be the brake power divided by the indicated power. Okay, Again, go to the next question. This is actually a problem. Okay. A refrigerator with a 2 kilowatt motor for powering the compressor gives 6000 kilojoule of cooling to the refrigerator space during 30 minutes of operation in a thermally insulated kitchen. Calculate the change in internal energy of the kitchen if the condenser coil behind the refrigerator rejects 8000 kilojoule of heat to kitchen over the same time period. Okay, this is the question. So when we read this question, it's, if you know the thermodynamics, the first law of thermodynamics, it's actually very well fitted in this types of questions. Okay, this questions related to the first law of thermodynamics, and we have to use it. Okay, so here, what are the things given? So delta Q is the heat of the kitchen is equal to 0. Why? Because thermally insulated kitchen. Okay. Okay. So then we have to write down the work. What is the work here? Electrical work. It's written a refrigerator with 2 kilowatt motor for powering the compressor. Okay, so that means the work is done on the system. Okay, we are doing the work. That means if you know the sign conventions of the thermodynamical systems, if the work is done on the system, it will be negative, and if the work is done by the system, it will be positive. So basically this will be your minus 2 kilowatt. For how much time it's they are doing the work? For 30 minutes. Okay, let's convert it into second, because kilowatt leads to kilojoule per second, and if you multiply it with by 60 second and convert it into second, we can get whatever the value in terms of what? Kilojoule. Okay, so let's apply first law of thermodynamics. Okay, so del U kitchen is equal to delta U kitchen equal to dou Q kitchen minus dou W electrical. Okay, this is the formula. So here you can see del W is 0, dou W, so dou Q is 0, so minus of minus 3600. Okay, so which is 3600 kilojoule, which leads to option of A. Okay, So the heat flow into a system is dash and heat flow out of the system is dash. Okay, this already I told. I can, so I can put one system here. So heat into the system always positive, heat out of the system always what? Negative. So where Q is equal to your what? Heat. So answer is your D. Okay. In which of the following system does mass transfer occurs? In which of the following systems does mass transfer occur across the system boundary? Mass transfer occurs across the system boundary. Boundary. So boundary word here is taken into consideration. Okay. So which of the system the uh, mass transfer is occurring in boundary means obviously mass is transferring means obviously open. If it is not a open system, the mass cannot be transferred. So you can see open system. The open system all also called as what? Control volume. Okay. So how to represent a open system or control volume? We have to represent through dotted lines. Okay. So and through this the mass can transfer. So and this is your system boundary. Okay. Okay. One more problem. A cylinder piston contains 1 kg methane gas at 100 kilopascal and 20 degrees Celsius. The gas is compressed reversibly to a pressure of 800 kilopascal. What is the work required if the process is isothermal? Okay, here also same question. We have to use first law. Okay, and one assumption given, that is isothermal process. Okay, so let's write what are the things given. So temperature is constant, which means isothermal process. So we know what is the internal energy is equal to mcv dt. So if your t is constant, that means your dt will be what? 0. That means your du will be equal to 0. Okay. So that means if du is equal to 0, that means by first law of thermodynamics, your W from 1 to 2 is equal to Q from 1 to 2. Okay. And also for the isothermal process, we know one formula that is equal to minus mRT ln P2 by P1. This you studied in your thermodynamics course. Okay. So what is the mass given in this question? 1 kg R. So you have to write down the R for the what? CH4. For methane, you know, it should be given in the question also 0.51835 kilojoule per kg Kelvin. Okay, so 1 into minus of 1 into 0.51835 mR now done. So what is the temperature? Temperature is 20 degree Celsius. So convert it into Kelvin. So 20 plus 273, 293 Kelvin into 293. Then what else? P2 by P1. Ln of P2 by P1. So what is P2? Your 800 kilopascal. And P1 is your 100 kilopascal. Okay. So if you solve it, just 1 second. Okay, so when you solve it, you will get W1 to 2 is equal to minus 316 kilojoule. So this is the answer. So if you see in the options, there also minus plus minus signs are also mentioned. So what does this minus sign means? This means work done on the system. Okay. So what is the option here? The option is B. Okay. So the last question. The entropy of an isolated system can never be what? So entropy, you always know, if a system is isolated, so the property of entropy, that entropy can remain constant for a reversible process and entropy will increase for a irreversible process. Okay, so for a isolated system, the same thing also valid, and the entropy can increase or remain constant, but it cannot decrease. So the option will be A. So this is what the case. So thank you very much for attending the section. We'll end this section with this questions. We'll meet in the next week. You can see whatever the content. If you missed anything, you can see in the, because I have to upload this thing in my YouTube channel also. So this is my YouTube channel link. This is my name also. You can directly write down without any space. This is the YouTube channel. Okay, and you can see the videos, all these videos whatever are available already, also see it, and the recording one also you can see. Okay, so we'll meet in the next week. Till then, if there is any doubt, you can ask in the comment section on my YouTube channel. Okay, if there is other doubts related to your course, you can ask in the question and answer forum in the NPTEL, and I can only solve the problems and some of the this theoretical some questions, okay, related to your uh, this subject. Okay, and if there is any doubt, you can related to my section, you can ask in my YouTube channel. uh, okay, so good night and happy learning.